Yeah, this one, W22, question paper 5-3. Starting, just two questions, starting with the first question. It says that a student attempts to determine the percentage by mass of magnesium chloride. So there is, he wants to figure out the percentage by mass of this thing. And in the solid mixture that contains, so there's a mixture that contains MgCl2 and magnesium nitrate using the following method. So he takes 1.5 grams of the solid mixture and records the mass. It dissolves the solid mixture in distilled water. So I think both of them will dissolve. Both of them are soluble. So the solution nitrates are also soluble. So the solution will have both things. So it becomes a solution. And then he adds silver nitrate. Now, silver nitrate, what silver nitrate is going to react with the chloride. Remember that the silver ions and the Cl ions, they react together and they would form a precipitate of AgCl. So now the solution will turn into a precipitate. He filters the solid mixture and washes the precipitate and collect it with distilled water, dries the precipitate in an oven, weighs the precipitate and records the mass. So he takes out the precipitate and then eventually records washes it, cleans it, dries it, and then eventually records the mass. Now, in this process, only the chloride ions from the magnesium chloride form a precipitate with the silver nitrate solution. So he's given us the equation as well. I wrote down the ionic equation. So he gave us the complete equation. Now, one student in the class obtains the following results. The mass of solid mixture is 1.52 grams. And the mass of AgCl solid after drying is 3.63 grams. Calculate the amount in moles of magnesium chloride present in the sample. So first thing is I can calculate the mass. I can calculate the moles of AgCl. So how do you calculate moles? Moles is mass divided by molar mass. So it's 3.60 grams. And we need to find out what's the molar mass of Ag. That's, I think that's 100. Can you double check? Can anyone double check? 107.9 plus Cl is 35.5, I think. So how many moles do we get for this?
Zero 0.02.
कितना 0.02?
जी
अच्छा,
और
so
वो Ag की वैल्यू ठीक है.
ठीक है. So you're getting 0.02 moles of AgCl. He gave us the equation. So 0.02 moles of AgCl. नहीं, आगे कुछ और था 0.02 after that. Was there anything else?
0.02531.
So always remember three significant figures. So 2531.
जी 0.02531.
Okay, so I'm going to take 0.0253 moles. So we were supposed to find the amount of magnesium chloride, the moles of magnesium chloride. So that's 2:1. So what is half of this? So
0.01265.
1265. So I'm going to write 127. 127 is fine. So I'm getting 0.0127 moles for this. Then I have used your answer to calculate the percentage of mass of magnesium chloride in the sample. So I know the moles of magnesium chloride. So I can find out the mass of magnesium chloride. So what will be the mass? It's going to be, just a second, multiplied by the MR. So 0.0127 moles, 127, not 172. Multiply MgCl2. What is MgCl2? That's 24.3, I think, is Mg, and Cl is 35.5, and times 2. So what do we get?
वन पॉइंट टू जीरो सिक्स सर ये रीचेक करवा लें
ठीक है 1.2.
1.206
So you're getting 1.206 grams, and the total mass of the solid mixture was 1.52 grams. So we had to figure out the percentage mass of MgCl2. So it's going to be the mass of MgCl2, which is 1.206, divided by 1.52. और मेरे ख्याल से ठीक होगा क्योंकि it's the total mass is 1.52, so multiplied by 100.
79%.
You see significant figures.
79.3 79.35 means 79.4.
So you're getting 79.4%. ठीक है, so you figured out the percentage. Suggest what the student could do in step 2 to ensure that the solid dissolves as quickly as possible. So how
increase the surface area by grinding it.
ठीक है, that's use to improve how the solid dissolves. Use powdered, more surface area. Or smaller pieces. So it dissolves more quickly. It's going to have more surface area. So it will quickly dissolve. Any other way? What could be an acceptable answer? Maybe stir more vigorously, right? That's one, or you can have a higher temperature as well. Things dissolve faster at higher temperatures as well.
Can we stir the mixture?
Honey, stir the mixture more quickly. That's another way to ensure that the solid dissolves. But I think the best one is this one. Use powdered smaller pieces, crush the solid into smaller pieces. Explain why the precipitate was washed with distilled water before it was. Why did you have to, like, when you took out this precipitate, why do you have to wash it?
So that it does not has any impurity.
And what is that impurity? To remove, I mean, these are your impurities, right? The unreacted reactants, right? So to remove any MgCl2 or magnesium or silver nitrate, because they are soluble. So agar iske upar if there's some of it still remaining on top of it, that will get washed away because these two are soluble. So remove any MgCl2 or silver nitrate. ठीक है, वो remove करने के लिए. Then suggest why the precipitate is dried in an oven and not by direct heating with a Bunsen burner. So the precipitate is MgCl2. Why are you not using a Bunsen burner?
Crystallization ना हो जाए.
Usually you avoid strong, when you're drying substances, you always avoid strong heating. Bunsen burner is it's a method of strong heating. To avoid strong heating so that it does not, it will decompose if it's heated very strongly. You just want the water to evaporate. The best way is to put it in sunlight. You don't want to, if you want just water to evaporate, water evaporates at 100 degrees centigrade. A Bunsen burner has a temperature of 1000 degrees centigrade. So a Bunsen burner is a very high temperature. So to avoid strong heating, so that MgCl2 does not decompose, you just want to get rid of the water. It does not decompose. As a step one, a small beaker was weighed. I think this is a separate question. A small beaker was weighed using a balance actuator, 2 decimal places, and its recorded mass recorded. The sample was placed in the beaker, and the mass of the beaker increased by 1.52 grams. Calculate the percentage error in the mass in measuring the mass of the sample. Show your working. Pehle to first thing, look at the reading and tell me what is the error in the reading. Like what's the rule for
3 significant figure?
error kya hota hai? What's the error? Like how do you calculate error in a device? Error is the smallest graduation divided by
measured multiply by 100.
नहीं पहले तो error क्या smallest graduation divided by
2.
divided by 2. You get whatever, like whenever you have, like if you have any apparatus, remember this. Okay, if this is 24.1 and this is 24.2 and this is 24.3, the smallest graduation is 0.1, right? So the error is always this thing. When someone says that the value is 24.3, it could mean anything that's between this range. Half a graduation up or half a graduation below. Any value that's close to 24.3 is read as 24.3. So the error is always half a graduation plus and half a graduation minus. So the range is between this. So it's always the smallest graduation divided by 2 plus minus.
सर
हाँ जी
तो ये जो आपने बताया ये हर apparatus के लिए होता है.
हाँ हर apparatus में रीडिंग्स होती है ना तो हर रीडिंग के अंदर यही होगा कि and remember the smallest graduation, always figure out this least count, that's 0.1, that's the smallest graduation, 0.1. Like if you have a thermometer might be in whole numbers, like it's going to have 1 degree centigrade, 2 degrees centigrade, 3 degrees centigrade, 4 degrees centigrade. So in this case as well, if something reads as 3, that means it could lie anywhere between this range. Half a graduation plus and half a graduation minus. Anything that's within that range, that would be called 3. So the error in the value will be plus minus the smallest graduation divided by 2. In this case, the smallest graduation is 0.01. And divide by 2, that will give you 0.005. So the error in the reading is plus minus 0.005. Is that clear?
Sir, 0.01 कहाँ से आया है?
वो भी smallest
0.1 नहीं होना चाहिए.
0.01. Now smallest graduation क्या है 1.52. So that means it can read up till 0.01.
Okay, okay.
ठीक है. I mean, for example, over here, if it's 24.2, the smallest graduation is 0.1, right?
Yes, sir.
ठीक है. Over here, the smallest graduation is 1. So over here, the error will be plus minus 0.5. ठीक है. So, but now there's another thing. ठीक है. You figured out what the error is. So we know what the error is. That's 0.005. But there's another problem. Okay. How would you figure out the mass of the sample in this case? Read the question carefully. Using a balance accurate to 2 decimal places, usse khud hi kaha 2 decimal places, 0.01, right? The sample was placed in the beaker and the mass of the beaker increased by 1.52. Now, whenever you measure the mass of a substance, what you'll do is you'll measure the mass of the beaker first, and then you'll place the substance, and then you'll measure the mass of the substance with the beaker, right? So how do you measure the mass of the substance that you added to the beaker? You're going to take a difference. It's going to be a difference that's going to be taken between the mass of the beaker plus the substance minus the mass of the beaker. Is that clear? Okay, that's how you measure mass of any substance. Is this clear?
Sir.
So basically, if you want to figure out the mass, like how did you figure out that the mass increased by 1.52? You took a difference, right? Whenever you take differences, addition or subtraction, both, the errors add up. So basically you're taking, and this happens in burette readings as well as mass readings. In mass readings, you have to take a difference. And in burette readings, final reading minus initial reading, you always have to take a difference. So whenever you take a difference, the error adds up. So basically your error is going to be double now. It's not going to be 0.005. It's actually going to be 0.005 multiplied by 2. So your value actually has an error of 0.005 multiplied by 2. अगर तो खाली एक value होती ना, if it had been a single value, then the error was 0.005. But if you're taking a difference, then the error gets multiplied by 2. Is this clear?
Sir, then why did we divide it? We could like let it remain the way it was.
हाँ, लेकिन हमने फिर सही तरीका किया ना. पहले तो we found out what is the error in a single reading. That was 0.005. But since you're taking a difference, the error gets added up, multiplied by 2. So you're going to multiply it by 2. वो ठीक है बात के वो तो वही आ गया. like this is the proper way. If you had not been actually, if you hadn't been taking a difference, then obviously it would have been just 0.005. Or times 100 color, you'll get the percentage. So the actual value is error divided by the actual value multiplied by 100. What do we get?
सर मेरी 0.657 वैल्यू आ रही है परसेंटेज के बाद
0.67.
657
तो यही होगी 0.657. Do you remember three?
Sir,
Yeah.
why did you times it by 2? 0.05 times 2?
Remember, did you get the point that when you have to measure mass, you always take a difference, right?
Yeah.
Like you're going to measure the mass of the beaker, then the mass of the beaker plus
Mass.
the solid, and then you're going to take a difference.
Mhm.
Remember,
Okay.
whenever you add two values or whenever you subtract two values, the error gets added up. Like for example, if I have a value which is it's got an error of 2 plus minus 0.5, let's say, and I've got another value which is 3 and it's plus minus 0.5 as well, right? If I add them up, the new value will be, it's 2 plus 3, that's going to be 5. But the error is now going to be double. It's going to be 0.1. Sorry, it's going to be 1. 0.5 plus 0.5 would give you 1. So remember this is a rule that whenever you add or subtract things, the error gets added up. Did you study this rule in physics, by the way?
Sir, I don't take physics, so I am not sure.
Okay, so basically, I'll just give you a brief background about why is the error getting added up, and it doesn't matter even if you subtract it, the error gets added up whenever you add or subtract two values, and the reason for that is, I mean, I can show you that the error in the new value is going to be 1. What is the minimum value for this thing? Like this means you got a range, right? The range is, this value could actually be 1.5 or it could be 2.5. It could be anything in between them, right? When I say that it's 2 plus minus 0.5, that could mean anything that's between 1.5 to 2.5, right? Based on the way it's written. Is this idea clear?
Yes, sir.
And if it's 3 plus minus 0.5, that means the value could be anywhere between 2.5 to 3.5, right?
Yes.
So when I take a difference, or sorry, when I add them up, what is the minimum value I'm going to get? I'm going to get, the minimum value I can get is 1.5 plus 2.5. That's what, 4, right? And what's the maximum value I can get? That's 2.5 plus 3.5. That's going to give me 6. So my value ranges from 4 to 6 now, right? So that's exactly what I'm getting. It's basically 2 plus 3, that's 5, with an error of 1 now, which means it could be 6, it could be 4 as well, or it could be anything in between. So do you see how the error is getting added up in your final value?
Yes, sir. Mhm.
Okay, so you don't have to, don't go into too much detail. That's more physics. I don't want to do a lot of math over here, but just keep it simple. Whenever you add or subtract values, the error gets added up. For example, if you have two Burette readings, like one Burette reading is 48.00 and the error is plus minus 0.05, and the other Burette reading is 23.00 plus minus 0.05 as well. And if you take the difference, 48 minus 23 is going to give you what, 25? And the error will get, it's going to be double now. It's going to be plus minus 0.1. So just remember this rule that errors in individual values will get added up if you take a difference or if you add them up. Is that clear?
Yeah.
Okay, so moving on. So that's the answer for the percentage error. Now moving on, other than by changing the balance state, how the percentage error could be reduced. So how can you reduce the percentage error? What is the formula of this? It's error over the actual value multiplied by 100, right?
Sir, increase the actual value.
Increasing the mass.
Okay, so one way, I mean, there are two ways of doing that, right? It's either you can change this or you can change this, right? So if you measure bigger values or use a larger mass of solid, like instead of using 1.52 grams, if you had a bigger mass, like 4 grams, the error would remain the same because your apparatus has the same error, right? So the error will kind of remain the same, but your value will increase. So the percentage error will decrease. So remember, in chemistry, you always use bigger values, bigger masses. So use a larger mass, that's it. Larger mass of the solid. So instead of taking 1.52 grams, use a bigger mass. Is that clear?
Yes, sir.
And he says without changing the balance. If they had allowed you to change the balance or change the apparatus, the other way of reducing this is by reducing the error. Use something that's more accurate. Like over here, the graduation, every single value had an error of plus minus 0.05. Use a device that has more graduations so that you have an even smaller error. So in that way as well, you can improve the percentage error. But for that, you would have to change the apparatus. You would have to use a higher accuracy weighing balance. Is that clear? You clear on this one?
Yes, sir.
As the next one is step 5. How do you ensure that the press plate was completely dry? When he was heating it in oven, how can you ensure that the press plate is completely dry and all the water is lost?
Measure the mass again.
Sir, there will be no change in the mass. No further.
I think exactly both things mean the same thing. So heat till constant mass, right? So what you're going to do is you're going to reweigh it until the mass stops changing. That's the next one. Another student in the class did not dry the silver chloride. State how that would affect the value of the percentage by mass of magnesium chloride. Now, if he's not drying it, right? So he's going to get a bigger mass. Like if you don't dry it, then obviously the mass will be bigger because it will contain water as well. So he will assume that he's got a bigger mass of AgCl. So if he has a bigger mass of AgCl, how would
the error reduces?
How would the value of the percentage by mass? Well, it reduces, it increases because where's the equation?
I
He
was
will assume
talking about the error.
error की बात नहीं हो रही, वो percentage. He's talking about the percentage composition.
Mhm.
If he does not remove the water, right? So he's going to get a bigger mass of AgCl, and he's going to get more moles of AgCl. If he gets more moles of AgCl, he'll also get more moles of MgCl2 as well. So he'll get a bigger mass of MgCl2 in the mixture, right? So that means his percentage will increase. Is that clear?
Yes, sir.
Because error ये आएगा कि water has not been removed, so the amount of AgCl, the mass of AgCl that he's calculating incorrectly is going to be a bigger value because it will contain water as well. More moles, then more moles of MgCl2, a bigger mass of MgCl2, and he'll get a higher percentage composition. So the answer to this part is bigger mass of AgCl, so more moles of MgCl2 will be calculated. So you're going to get a higher percentage composition. Okay, now moving to question number 2 now. Achha, he's got this question states that for a fixed mass of gas at constant pressure, its volume is proportional to its absolute temperature. So he's saying that for a gas, the temperature and the volume are proportional. That's the first statement. And then he says most gases are non-ideal and do not obey this law. But at lower pressures and higher temperatures, some gases are close to ideal behavior. One gas that behaves like this is oxygen gas. So he's saying that gases don't behave ideally, but at low pressures and high temperatures, gases come very close to ideal gas behavior. So this law over here, it becomes valid under those conditions. Now he says that oxygen can be prepared by decomposition. So there's oxygen gas being prepared. And he's told us that H2O2 is very corrosive, so to the skin. So wear gloves. And it causes eye irritation, so wear protective goggles as well. He's going to ask about that. Now, once the apparatus is assembled, the volume of oxygen in the gas syringe is 2 cm cube. There are 80 cm cube oxygen remaining in the flask. The total volume of oxygen is 82 cm cube. What did he mean by this? Once the apparatus is assembled, the volume of oxygen in the gas syringe is 2 centimeter cube. So there's 2 centimeter cube of oxygen. There are 80 cm cube of oxygen remaining in the flask. So there's 80 cm cube over here. So I don't know what he means by this, but he's saying that there's 80 cm cube over here, and there's barely 2 cm cube in the gas syringe. That is what he meant, right? So, and there's only oxygen gas in the flask. Record this temperature and the total volume of oxygen reading on the syringe. Gently heat the apparatus under temperature reaches 30 centigrade and records. So he's basically, now what he's doing is that he's heating it and he's increasing temperature. And he's saying, he's trying to figure out how the volume will change. So the gas would probably expand and the syringe will get pushed upwards, right? It's going to have a larger volume because of the greater expansion. Now gently heat the apparatus until it reaches 30 centigrade, record the total volume of oxygen, repeat at intervals of 5 centigrade until the temperature. So what he's doing is he's increasing temperature from 30 degrees centigrade to 70 degrees centigrade at 5 degrees centigrade intervals. And he's going to record the total volume of oxygen. And he's going to give you a table which has all of that. And other than wearing of safety goggles, give a safety precaution that the student must take. So that's protective gloves. Complete the following diagram to show how the student can obtain oxygen by gas collection over water for use. Now he's saying collect the gases over water, right? And so this is the reaction. Over water means that you'll have a tube. And there could be a trough.
Collecting gas using by downward delivery.
Nee, over water. Over water means you have to bubble it through water.
Oh, sir, ये इसको downward delivery नहीं कहते?
Nee, downward delivery is something else. The downward delivery is for heavy gases. You just have a flask and the gas particles would just fill up the flask. That's it. They wouldn't be able to come out because they're heavy gases. Over water is you over water and you bubble it through water.
Sir, एक upward delivery भी होती थी, वो कौन सी है?
Upward delivery is for light gases. If you have light gases, so just put the flask upside down and the light gases will get stuck in the flask. That's it. So यहाँ पे you're basically bubbling it and the gases will get, you have to make sure there are no gaps, make a better drawing. So I guess that's it. So you can have an inverted measuring cylinder, you can collect the gases. So this is how the student could ensure that they collect pure oxygen gas in the colonel flask. How can you ensure that you get pure oxygen gas over here?
Making sure that water is clean so that The oxygen which is traveling from it is clean. I'm
If
not
you
sure.
what is the only thing that will contaminate this oxygen gas? I mean, there's obviously oxygen gas being produced, right? So what is the thing that will contaminate the oxygen gas over here? Yahan pe.
If there is a gas bubble,
Hydrogen.
or maybe if the beaker
Uh-huh.
is not washed.
So for this, it's light by mean mass. It's the only thing that will contaminate is air. Because before the experiment started, the flask over here had air in it. So initially, even before oxygen started getting produced, the entire tube, etc., everything would be filled with air, right? So initially, the first few particles that will be pushed, वो बाद में oxygen gas starts getting produced, right? So it's going to push the air into this over here, into this pocket over here. So the idea is that you don't use the first few samples because they'll be contaminated by air. Okay, so don't collect the initial gas, like let it bubble. Don't put the put this inverted measuring cylinder on top initially. Is this clear?
Yes, sir.
And remember, this is a problem in all, whenever you have to collect gases, the first sample is just going to be air, because before the apparatus is ready to be used, it's already filled with air. So before you can collect any gas that's going to be produced, the first sample is always going to be of air. That's going to be pushed into the flask over here. So you don't initially collect the gas. You allow the experiment to run for a while, so that, I mean, the flask over here is full of oxygen, and then you put the measuring cylinder on top. Honey, the pencil is fine. The only thing I think is you just have to, I guess, label this, and in every gas collection experiment, make sure that it's leak proof. There are no gaps anywhere. That's the next one. Plot a graph on the grid to show how the relationship between the volume of oxygen and absolute temperature. Use cross to plot each point. So we've got to plot all these points on a graph. So what I'm going to do is, let's start plotting it quickly. The first one is 24, and we had to plot what? Absolute temperature or what? Yep, absolute temperature. So the first points are 297, 82, and 84. Just a second, 297. Where's 297? I guess that's this point.
सर मैं आपको पॉइंट्स बताती जाती हूँ, मैंने स्क्रीनशॉट ले लिया उसका.
ठीक है, बता दो. 297, it's 82.
And second is 303 absolute temperature and gas is 84.
So this one is 84.
Third is 308 and 88.
308 and so all the way up. It's this one.
313 and 88.
313 again, 88.
Ji.
So 313, that's again 88.
318, 89.
And 89.
323.
89 बीच में होगा ना, that's 89, right?
Ji. 323, 91.
323 and 91. That's this.
328 93.
93.
जी.
Yeah, 93. फिर after that,
333 95.
333 and 95. That's probably this.
338 97.
And 97. Just a second. But see, I think we've any other point after that.
आखिरी बस रह गया 343 98.
343 and 98. I think that's this one. So, okay, so we've got a rough sketch, and what did he say? Did he ask us to draw to show the relationship, draw a line of best fit? So you have to draw. I think it's going to be a straight line. So I don't have a ruler, so probably just make sure. I mean, this is an anomalous point, so don't put this in the line. So it's probably going to be something like this, TK. So that's just a rough line. You'll have a ruler to do this with. So that's your best fit line. Determine the gradient of your line of best fit. State the coordinates of both points. So gradient, make sure to have as big of a triangle as possible. So I'm going to take, let's say it's passing this point. So the rise is 80 to 94. That's what 80 to 94? That's 14 cm cube. And 330, 290 to 330, that's 40 Kelvins. So what do we get? 14 divided by 40, what do we get?
0.35.
Okay, so we're getting 0.35. Third क्या था number, significant figure?
बस सर इतना ही है.
So 0.35. I said then you have circle the anomalous point. We already did that. So just a possible explanation for this. So why do we have an anomalous point over here? That's probably because I think
आपने कहा था कि फर्स्ट वाली नहीं लेते. वो तो नहीं है जब फर्स्ट गैस कलेक्शन गलत आई थी.
No, it's the experiment is going on, and in the middle you have an incorrect value.
Human error.
What could be the error in this case?
Incorrect measurement of volume of oxygen.
Okay, that's one incorrect measurement of the volume of oxygen gas. Okay, मतलब हो सकता है यहाँ पे हो and he's measuring it much higher up. Okay, that could be one, or it could be taken at the wrong time. That could also be. It could be. I mean, you're taking a reading at the wrong interval, at the wrong temperature. Okay, maybe so that could be another one. Okay, maybe
So
this
we are
point
taking
was.
it at the lower temperature, right? We're taking the reading at a lower temperature.
You're taking. The actual temperature might have been this one, but you're thinking, or maybe you took it earlier, so you're getting a lower temperature, which is why you made an error somewhere while recording the temperature. Okay, so
Right.
both things are possible. Maybe the volume measured was incorrectly measured, volume of gas, or the actual temperature was higher than the recorded one, but it would probably be somewhere over here close to the line, but you think that it's slightly lower than that. So the actual temperature measured, actual temperature of the reading was probably a higher temperature and was measured incorrectly. I say, whenever they ask about the anomalous point, they always look for, although both, I mean, it could be an error in this, or it could be an error in this one. It could be an error in the independent variable, or it could be an error in the dependent variable. But usually in the marking schemes, it's usually, normally they look for the explanation according to the independent variable. If something went wrong over here, like while you're measuring the volume at this point, you maybe took the wrong temperature. Okay, so always comment on the independent variable, not on the dependent one. Is that clear?
Yes, sir.
So the next one is identify the independent variable that was temperature in Kelvins. Obviously, the absolute temperature. Suggest more reliable.
Repeat the experiment.
Uska simple repeat the experiment. Finally, you've got the ideal gas equation is shown. That's the last question. He says the pressure of the gas PA V equals volume of gas in meter cube, the number of moles of gas. So everything is given. Use this equation to describe how the gradient of the graph you've plotted would be affected by using a smaller volume of oxygen at the start of the experiment. So you've got a PV0 nRT equation. Using this equation, describe how the gradient of the graph you've plotted would be affected by using a smaller volume of oxygen at the start of the explain your answer. So PV0 nRT. So what is the gradient of the graph? Like, what does the gradient of the graph represent? It's volume over temperature, right? So it's volume over temperature. So volume over temperature, that's the gradient. Okay. So using this equation, describe how the student you've plotted and
सर आपने T 2 बार क्यों लिख दी है?
हाँ T निकल गया, P लिख देते हैं. अच्छा V over T, that's your gradient, right?
जी.
Now tell me, if you had used a smaller volume of oxygen, how would the gradient be affected? Well, I've rearranged it. Okay? V over T, that's your gradient of the graph. Your graph is volume plotted versus time, right? So the gradient is basically V over T. So if you had used a smaller volume in the whole apparatus, so how would this gradient be affected? Your moles of oxygen, will they be more or less?
Less.
R the constant, right?
जी.
So you'll have fewer moles of gas, right? If you have fewer moles of gas, your gradient would be lesser. It's directly proportional to moles of gas. I mean, V over T is directly proportional to, it's directly proportional to N. Is that clear?
Yes, sir.
So, होगा ये कि start when I write is the start. Where's the start? I mean, this apparatus. If you had used a smaller volume of gas, then you know that V over T is basically equal to the moles into R into over P.
Over P. Sir, ये कह सकते हैं कि अगर V over T की आप V की छोटी वैल्यू ले रहे हैं तो the pressure increases?
No, we don't care about V over T. I think he's doing everything at constant pressure.
Okay.
So, I mean, it is atmospheric pressure. It is constant pressure. I mean, nowhere is he adding extra pressure, right? Everything is happening at constant pressure. So the pressure remains the same.
Right.
R is also a constant. The only thing you're changing is N, which is the moles of gas. So V over T is the gradient. So that will have a smaller value because it's directly proportional to moles of gas. Is this clear?
Yes, sir.
चलो ठीक है. चलिए ये खत्म हो गया पेपर, ठीक है? कल पे कंटिन्यू करते हैं.
सर
हाँ जी.
सर केमिस्ट्री में लाइन ऑफ वर्स्ट फिट पूछते हैं वो.
Line of?
Line of worst fit, I think that's what they call it.
नहीं, ऐसी वैसे कोई चीज होती नहीं है. मैंने पहली दफा सुना. बेस्ट फिट ही होती है.
फिजिक्स में होता है उसमें.
फिजिक्स में वर्स्ट फिट होता है. वर्स्ट फिट
जी सर.
वर्स्ट फिट की क्या सेंस बनती है? कोई सेंस नहीं बनती वर्स्ट फिट. अच्छा होता होगा फिजिक्स में, मुझे नहीं पता. लेकिन नहीं, केमिस्ट्री में there's no worst fit, ठीक है?
Okay.
चल ओके, ठीक है.
अल्लाह हाफिज.
हाफिज.
सर रमजान में सेम टाइमिंग होगी?
नहीं वो मैं चेंज करूंगा. Obviously it's I think at this class.
Yeah.
Yeah, I'll probably क्योंकि Taraweeh and Maghrib, ठीक है. It's either going to be it's probably going to be after Taraweeh then. Maybe 10 or something like that.
Okay, sir.
चलें, okay. हाफिज.
हाँ.